This is the second of the two videos demonstrating the chi-squared goodness of fit test for normal distribution. In the previous video, we looked at the first three steps. Step 1, set up the hypothesis. Step 2, collect the random sample and compute sample mean and sample standard deviation. Step 3, set up the class intervals and the class upper limits, and for that you have to first find number of classes by dividing the sample size by 5 and then round it down. Then 1 over k is the probability for each class, and then come up with the cumulative probability such that the total probability is 1, and then use norm.inv with the cumulative probability to determine the upper class limit. The next step is to actually compute the frequencies for each of those classes. The frequencies are computed using an Excel function called frequency, but we have to set it up as an array function. So that is a special type of function. So I'll demonstrate how to do that. So now we have the class upper limits already set up from the previous video. Now we have the scores, the sample data. Now we have to summarize the sample data into these classes, and we're going to use the array frequency function for that. So highlight not just one cell but the entire range of cells adjacent to the class upper limits. And then you type the function frequency, and the data array is score. The bins array is the class upper limits. Now close parenthesis. Now don't press the enter key. So instead, this is what makes it an array function. You have to press shift control, the two keys down. Okay, shift and control, keep it down, press it down, don't let it go, and then press the enter key. Now that enters the frequency function in all of these cells in the range, and it gives you the frequencies. So let's sum the frequencies and make sure that it has 50, which is our sample size right here. So all the observations are now summarized in the observed frequencies, and the expected frequency is n over k, sample size over k. And we'll make that absolute reference for both of them. So that will be our expected frequency, which then let's sum that and make sure that we have all the 50 accounted for. So now we have the observed frequencies, we have the expected frequencies. Now we can set up our chi-squared. Observed frequency minus expected frequency squared divided by expected frequency. Now sum that. That is our chi-squared value. Now the degrees of freedom is k minus 3 in the case of normal distribution. So we have k over there minus 3, and the p-value is chi-sq.dis.rt, the chi-squared statistic value, and then the degrees of freedom. So the p-value is 49.39%, and therefore our conclusion is, since p-value is greater than 5%, do not reject the null hypothesis. And the interpretation is that we do not have sufficient evidence to reject the null hypothesis. So we cannot say that it does not follow normal distribution.
So we do not have sufficient evidence to conclude that the aptitude test scores do not follow normal distribution with mean of 68.42 and standard deviation 10.41. So if we concluded that it does not follow normal distribution, then the probability that it is wrong is 49.39%.